We're looking into image segmentation using Detectron2, which is Facebook's object detection library. I'm doing this on Colab, and you can see there are 4 steps in this process. One is installing the dependencies, cloning the repository itself, and you have importing all the libraries that we need. And lastly, we'll run a simple inference on the video. This is just the demo version of the project. Later on, we will see how we can train our own data sets, how to use Detectron2. So you just go to runtime, look into change runtime type, and this should be set up to GPU. Normally, it will be set up as none, but in this case, we do need the GPUs, and we just say hardware accelerator is GPU. So let's go about installing all the dependencies that we would need for this project. First and foremost, we need PyYAML, which is pip install PyYAML. And for this purpose, we're using version 5.1. PyYAML is nothing but a data serialization library. So you can convert a JSON into a serial, from serial to JSON, vice versa. So a more human and user-friendly format. We also need Torch, because the whole Detectron2 library was developed for PyTorch. You have import Torch. Now, based on the version of Torch that you have at that moment, you want to install or download all the libraries that we need from Facebook. For that purpose, we first need to find out what Torch and CUDA version we are running. So we just type print torch dot version _, and just run this. And it'll take a few seconds. It'll install all the libraries, and towards the end, it'll give us the version for Torch and CUDA. And in my case, it is 1.10 for Torch, and CUDA is CU111. Now, using this information, we will download the files that we need from Facebook. So for that purpose, we'll do pip install Detectron2 file, and you have a link that goes by https directory listing. Then you have Facebook FB AI public file.com. And other than that, you have a Detectron2 folder. Under Detectron2, we'll look into the wheel, and here you put down the CUDA version that we want, the CU111 in our case. And then we have Torch, the version number 1.10. And at the end, we do index.html. As simple as that. We just run this, and it should hopefully download all the Detectron2 files that we need. Another thing that I did here was just uploaded a sample video that I would be using for this purpose. I just uploaded a random video, and up here you just go in and click on upload to the session storage, and it'll upload that video. And then hence we can use this for the inference purpose that we will do in the next stage. So it looks like Detectron2 was installed by the firm from Facebook, and we just click on restart runtime, and it's okay. Once we have all that set up, now we go into cloning the repository that we would need. And for that purpose, we will use the Facebook's Detectron2 library, which is here, Facebook Research Detectron2. We just copy this code that we have here, come down here, and clone the repository that we need. So git clone the repository that we need. And just play this, and it'll copy all the Detectron2 libraries that we need for this purpose, and you will see a Detectron2 folder created here in the file directory. Now, let's start importing all the libraries. This is the fun stuff. Now, for the first thing we do is import Detectron2. Done. Then from Detectron, we'll have some logger files that it will be using from Detectron2.utilities.logger import setup logger. Once we have that set up, then you just initialize the setup logger. Most of these steps are already gone by Facebook's GitHub repository. It's easy for us to run down here. Then we will need NumPy as an import. NumPy as NP. We have import OS JSON, CV2, OpenCV, and then we have random. We will also use Google Colab patches if we want to display the frame on our Colab, but in this case, we don't need it. Next, we have from Detectron2, import model zoo. Then you have, next step is all the default predictions, the configuration files, the visualizations, and the catalog file. So next step is the detector. We can take Detectron2 engine, import default predictor. Then from, again, Detectron2 config, import get EFG configuration. Again, from Detectron2 utilities dot visualizer, import visualizer. This is very helpful, especially when we're doing our own data set that we'll be trading. It'll help us in visualizing, but here just importing all the libraries that we need. From Detectron2 data, import metadata. This is for storing the metadata in the dataset catalog. Everything is done. We just imported all the libraries, and we just run this. So it looks like there's an error here, and we missed the E in engine. Replace that and fix it. It looks like there is one mistake here. Again, the visualizer. Visualizer is with a capital V. We just put V here, and it looks like everything imported seamlessly. So that looks good. The next thing is here, if you go into the directory, under Detectron2, there's a demo folder, and under demo, there's a demo.py. This demo.py is basically the reference number or what we'll be using to run the inference on the video. The way to run that is simply by percentile, and this is simply because we're using Colab, and we do run. Under Detectron2's folder, we have the demo folder that we saw, and under that, we have the demo.py file. And this demo.py file takes a set of arguments. There are a couple of arguments, about four or five arguments that it needs. And I have all of this copied here in another folder. I'll just copy from here and paste them, and I'll walk you through what's happening here. So one is the first argument is the configuration file, and this is present again in the Detectron2 folder under configs. And here we are using a Coco Panoptics segmentation file. The Detectron2 comes in with many other segmentation libraries, but for this purpose, we're just using Panoptics segmentation. Nothing particular. You can try others that are available as well. Based on that, you will also need to change the model.weights file. Once we have the configuration file set up, we are just inputting the video input, the video that we uploaded here. In my case, since I have this cars.mp4 file listed here, so I'm just saying video input cars.mp4. And you'll see this / towards the end. The reason for that is this is showing the code that the whole argument set, this whole 6 lines, is nothing but running Detectron2 along with the argument. So this is just giving instructions to the code that the / means I'm still continuing, and the next line that you see is nothing but part of my original code. Then you're giving the confidence threshold that's needed. The output video, once you start running it, the output would be created again in this file directory with the name video-output.mkv. And towards the end, when you also need to provide the weights file, which is given here in this particular folder. Once you have everything set up, just simply go ahead and run it, and it'll start running the inference on the video. In our case, it'll take some time since we are, again, using the Colab. Just click on run, and it'll take a few minutes and go through all the frames within the video based on the video size and the size of, frame size and everything. It'll take some time and then come back to you. So let it run in the background, and we'll come back and see. Once everything is done, this particular video was only for the demo version. The next stage would be more in regards to how we can do our own data set, how we can train on our own data set and run it.